we want to have multiple components working together inside a single actor that we can place in our level, we will first of all need to create the blueprint that will contain the static mesh and blueprint code that will ultimately become our automatic door. To make a start from inside the Unreal Content Browser, let's make sure that we are in the first-person BP, BP for ArchViz, AutoDoor folders, where we can right-click and then choose the Blueprint class option from inside the Create Basic Assets section. In the Pick Parent Class dialog box, let's choose Actor from the Common Classes section, and then name it BP _ AutoDoor. As good organization is key on any project, splitting our blueprints into separate folders will help us navigate straight to the actor that we want to edit, without having to potentially scroll through hundreds of options. An actor simply being any object that can be put into a level. Now, when we use the term actors, it is really just a generic class that lets us apply transform operations such as translation, rotation, and scale. Now, there are different types of actors that we can use in Unreal, and we will see a couple of these used throughout the duration of the course. Some being particularly useful because they can be created or spawned, if we want to use game terminology, at runtime, and can also be destroyed whenever required, this being possible via both C++ and blueprints. The blueprint actor that we have created here will also allow us to add functionality or gameplay via C++ or blueprints to any of the components that we will be adding. At this moment in time, of course, we don't have anything that resembles an automatic door in our scene, as all we have is the billboard of our default scene route. To make a start at fixing this, we can double-click the new blueprint to open up the Asset Editor, making sure we're inside the Viewport tab. And then, after adjusting the window so that we can see the Unreal Content Browser, click and drag the AutoDoor _ frame static mesh into the Components section, making sure to place it onto the default scene route component that already resides there. Although we created the blueprint actor earlier, it was, by default, simply an empty container, but here we see that we are able to add static mesh files to it, although we could also add light actors, camera actors, and even particle systems into it as components if needed, making it a very powerful tool for visualization projects. If you are wondering why we placed the static mesh onto the default scene route component as we dropped it in, well, this is because actors in Unreal don't directly store transform, so position, rotation, and scale data, as this is actually stored inside an actor's route component, such as our default scene route here. By dropping the mesh onto that then, we have made the frame mesh a child of the route. Starting the building process with the frame mesh means that we can also very clearly see where we want to place the other static mesh files that will act as the left and right sliding doors. To start adding those, we can drag and drop the AutoDoor static mesh onto the AutoDoor frame entry and call it AutoDoor _ L. Inside the Details tab, let's then set its Y location to a value of -47.5. What we are seeing now then is that we can actually add multiple mesh actors to a blueprint, and so are not just limited to one. In fact, building this blueprint using multiple static mesh files means that we now have the flexibility to use the actor that we are building in another blueprint if we wish. It also means that we can assign some very specific blueprint logic to just this mesh alone. The values used for placement in a level will be dependent on the scale of the scene and may require a bit of calculation based on static mesh scale as well. If we don't know the scale, then we may just have to eyeball moving it into place via the transform gizmos. It is also worth noting here that we made the door a child of the frame static mesh by dragging it onto the frame component, so that should we need to change the orientation of the frame inside the blueprint at any time, then the doors will go along for the ride, saving us the trouble of needing to rotate all three static mesh components individually. So we have our left-hand door placed and ready to go, but we will obviously need a right-hand door as well. Now the problem is, we only have one static mesh. Not to worry though, as we can easily reuse this mesh in order to give us exactly what we need. Let's again drag our auto door mesh onto the components rollout, and this time name it AutoDoor_R, after which we can make sure it is a child of the auto door frame mesh. Inside the transform section of the details tab, we can set its Y location to 47.5, and then, after making sure that the scale parameter isn't locked, set the Y scale value to -1. If you are wondering why we have applied a -1 value to the scale parameter, well, if we take a look in the viewport, we can see an arrow inside the actor's texture that I added so as to show the travel direction of the door to the user, just as you might find in real life. Now, if I just rotated this copy of the mesh and then tried to continue using this same texture, the arrow would obviously be pointing in the wrong direction. Worse still would be the fact that any positional features that might be modeled into the mesh, such as a door handle for instance, would also be in the wrong place. Simply inverting the scale of the mesh, though, means that everything is exactly where we need it to be without having to create a separate mesh or material, thus letting the transform data in Unreal do the hard work for us. Now, this just makes scene management a little easier as we are reusing assets rather than continually importing new ones. The construction of the door has come together nicely then, but it's time now to focus our attention on the functionality of our blueprint. In other words, we need to consider how we tell the engine to execute the blueprint code that we will be adding later so as to open the doors automatically. With the auto door frame component selected then, let's click the Add Components button, type box into the search field, and then click to add a box collision component to our actor blueprint. We can give it a descriptive name if we wish, with something like door_trigger working for us in this instance. What the box collision component allows us to do is set a volume that tells the blueprint when the player has collided with the object, but without obstructing the player's ability to traverse the level. This is perfect for an automatic door, as we can easily test when the player has collided with the component, and then execute an action or actions that we will set up inside the actor's blueprint. As it stands, the player will have to practically squash their face up to the glass before they hit the collision component, which is not what we want for our automatic door. Inside the transform section of the details tab then, let's set its Z location to a value of 84, and then, after making sure that the scale values are not locked, use X, Y, and Z values of 4, 3, and 2.5 respectively, after which we can click Compile and Save. The position and scale of the collision component may take a little bit of trial and error if you are setting up a custom actor. But what we want, though, is for the doors to open when the player is standing roughly in front of them, so not the glass sides. And we want this to happen at a bit of a distance so as to feel natural. Now, do feel free to experiment with the position and scale of this component later on, though, once we have completed the blueprint, in order to see how it affects the interaction with the door. And with that, we have our visuals for the automatic door in place, as well as the collision component that will be vital in terms of getting our blueprint code to work properly, and so make our static mesh behave and function like an automatic door. Knowing how to both create blueprint actors and add components to them, as well as the need to think about what we need them to accomplish inside our visualization, is definitely going to serve us well on any project that we work on.